In this lesson, we're going to take a look at similar triangles for side, 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 and side, angle, side. And so this is super similar to when we did congruence, but this one is similar. And so if we have sides that are proportional, and again, angles have to be congruent, or if we have all three sides proportional, then those triangles are similar. So let's take a look at this one. PR, we would go ahead and put an 8, SR, 20, and then we can reduce that to 2/5, or sometimes a decimal might help so that we can compare them, because sometimes even simplified fractions may be a little bit different, but then if you really just divide them, 2 divided by 5 is 0.4, you can see it clearly to compare. So then we fill in the rest here, PQ, ST, reduce, take a 3 out of both, and that is also 2/5 or 0.4. And then this one is going to be 5 over 12.5, which, how would we reduce that? Because it's a decimal. So again, 5 divided by 12.5, if we do that in our calculator, we can see it is 0.4. So these are all proportional, and so yes, triangles are similar. So sometimes just changing it into a decimal to compare might assist you if you're not the best at reducing. All right, so now we're going to go ahead and compare these. We're going to compare PR, that base, with SU. We're going to compare PQ, and you can kind of look first two, so first two, ST, so kind of like we talked about when we name them back when we were doing congruence. And the last one be QR, and if it's the last two, then it should be TU that it's matching up with. So now we can go ahead and kind of look at those relationships. So PR is 2, and SU is 3. PQ is 3, ST was 4.5, and that is also 2/3, or again, you could do it decimal, 0.6 repeating. That's 0.6 repeating when you divide it in your calculator. And then 3 over 4.5 is also 2/3 or 0.6 repeating. And so yes, triangle PQR is similar to triangle STU by side, side, side similarity. And so this is our similarity statement, and then this is our reasoning, side, side, side similarity. So on this next one, we can already see that the angles are congruent. D is congruent to H. And then we are going to compare the sides, the two sides, DE and HJ, and DF and HK. So 2 over 1, 5.8 over 2.9, which is 2 over 1, or 2. So we have a side, an angle, and then a side. So yes, triangles are similar. By side, angle, side similarity, so triangle DEF similar to triangle HJK. So here is our next one, and this one, change my color here, we are going to take and compare I'm going to do 10. So this is my little triangle, and then I also have my big triangle. So I'm going to go ahead and add these up for those big long sides here of the triangle. So 10 is going to compare to 25, and then 12 is going to compare to 30. So I have small side to long side, and then small side to long side. And then I'm going to cross multiply. And 300 is equal to 300. So we have our side, angle, side similarity. triangles. If I can make my, there we go, my little squiggly. Similar by side angle side similarity. And we could just go ahead and change that into a similarity, and there's my similarity statement right there. All right, so now we've got some parallel lines. Again, we have our angle here, we have our vertical angles here as well, and so we have angle, we know they're similar. We can go ahead and set up our proportion. So I'm going to go ahead and go from big triangle to little triangle, base over base, big to little is equal to big to little. So 2x plus 10 has to go on top, and little x plus 3 has to go on the bottom. So make sure you know which direction you're going, and make sure you go that same direction for both proportions. Cross multiply, we got some distributing. And then some solving. So x is equal to 10, and then it wants us to plug it back in to find RQ and QT. So RQ up here is going to be 5 plus 3, which is 8. And then down here, 2 times 5 plus 10, which would be 20. So mid-segment is actually in 8.5, but we're going to go ahead and talk about it now since this one's a little bit of a shorter unit. But mid-segment, I've done something sort of similar to it, but basically FG, if we cut it in half, we would get JK. It's mid-segment. And vice versa, if we wanted to go this direction, we would just double JK to get FG. So if I'm looking for DE, I look for the segment that's kind of parallel to it, and it's 15. So I'm going to cut it in half to find this shorter, smaller segment here. So half of 15 would mean that this would be 7.5 for DE. If I wanted to find this little segment here, well, I know that this is 9.2, so I know this whole thing is double, so 18.4, and so then this little section right here would just be 9.2. Angle FED. FED is this angle right there. And so we have parallel lines. And when we have parallel lines and we have a transversal, alternate interior are going to be the same. So that would be 82 degrees there. If BC, let's find BC here. Oh, this one was 24. What would DF be? So that's a mid-segment that would be across from, so it'd be half of 24. 24 divided by 2, it would be 12. So if you want to go ahead and try example 5 on your own, you can pause the video, try it. It's just like the one up above, and push play to check when you're ready. All right, so this one's going to be half of 98. And that would be 49. ST, this one is double, so 44 times 2, so 88. And then our angle here, XYT, well, those are supplementary because they're not alternate, so that would mean that it would be 180 minus 115, so 65 degrees. And then here's just a recap of the 3 we talked about, that one from 8.3 and these 2 from 8.4.